Welcome to today's episode. Today we will explore a topic that we may not often encounter. Old mining dumps may appear as just hills in the landscape, but they can be unexpectedly active even thermally. We will examine an exciting project that utilizes modern technology to monitor these dumps.
It's not just about ecology, although that is of course important, but mainly about safety. These dumps can spontaneously combust, often hidden inside, releasing dangerous gases into the surrounding area. So, monitoring is important.
Okay. Who is behind this project? Who is trying to manage these risks?
It's a team of experts from the Faculty of Electrical Engineering and Computer Science at the Technical University of Ostrava, from the Department of Cybernetics and Biomedical Engineering.
And what exactly are they focusing on when measuring? Is it just the surface temperature?
Temperature is, of course, fundamental, but it is measured not only on the surface, but also at various depths. This allows us to obtain a 3D temperature profile of the spoil heap. But equally important, if not more important, is monitoring gas concentrations.
And which gases are problematic?
Mainly carbon monoxide, then hydrogen sulfide, and also benzene. These are gases that typically indicate undesirable processes are occurring inside the dump. Oxygen is also measured.
Why oxygen?
Because its concentration tells us how much the environment is ready for combustion. Higher oxygen concentrations mean a higher risk.
And is this already in use somewhere?
Yes, the technology is already being tested in practice in the Ostrava region at the Hezmanis spoil mining dump.
What is being measured there?
Comprehensive measurements of both temperature at various depths and gas concentrations are being carried out there. The second location is near Pilsen, at the Krimik spoil mining dump. There, they are currently focusing mainly on measuring temperature profiles.
And what does the technology look like in the field?
Wireless sensors are used, which is one of the great advantages. They are simply placed directly in the spoil mining dump at various locations and depths. IQRF wireless technology is used for data transmission. It has two essential features for this environment.
Tell us more.
First, it has extremely low power consumption. This means that sensors can operate on a single battery for many years without needing replacement.
Which is invaluable in a place like this.
Exactly. In the difficult-to-access terrain of the spoil heap, this is a huge advantage. And secondly, it works in a so-called mesh topology. We can imagine it as a durable spiderweb. It's not that the data has to go only once in a direct path from the sensors to the control center.
I see.
The network is designed so that data can jump between individual devices. If a path is blocked, for example, due to an obstacle, or if one device fails, the message automatically finds an alternative route through other nodes in the network.
That sounds very reliable.
Yes, it is. It ensures reliable data transmission even in the harsh conditions that prevail on the dumps. Dust, humidity, temperature changes. Thanks to this, we have continuous data, temperature profiles, and gas concentrations, allowing us to monitor the dynamics of how everything develops over time.
So to sum up, what are the main benefits?
I see the main benefits as follows. First, early detection. The system can detect an incipient problem, whether it is a rise in temperature signaling a risk of spontaneous combustion or a gas leak, much, much earlier.
Before the human inspection would notice it.
Exactly. Second, autonomous operation. Thanks to long-life batteries and a reliable network, it requires minimal maintenance.
Which saves money and time associated with maintenance.
Yes. And third, we can mention the reduced risk to personnel. The need for frequent visits by technicians to potentially dangerous terrain is minimized.
So the result is actually a safer environment, more efficient management of these old environmental burdens, and a better protected climate. It's fascinating how technology allows us to see beneath the surface literally.
That's right. It's a nice example of how the so-called Internet of Things can help solve particular problems in the real world. The data allows us to respond, but also to better understand processes and anticipate issues before they become serious.
Thank you for listening, and see you next time for the next episode of our podcasts.